Hello! Welcome to How to Perform Deep Learning Inference in Simulink. Whether you want to test your model in a simulation environment or are trying to deploy a model to hardware, there are many cases where you may want to bring a pre-trained neural network into Simulink. For today's example, I will be performing object detection on a video captured by an underwater vehicle as shown here. In order to do this, we will go through the video frame by frame and use a trained neural network to detect the desired objects in each frame. Let's start by taking a look at the video footage we will be working with. As you can see, this video was captured underwater, and there are a few different types of objects of interest. The ones we will be detecting today are the yellow gates, as well as the yellow, red, and green buoys. I have trained a neural network to do this, which we will be using in this example. To learn more about how this model was created, check out our series on object detection linked in the description. Once you have a trained neural network in MATLAB, you're ready to bring it into Simulink. In this Simulink model, we have one block that is responsible for importing the input data, 4 blocks for video processing and prediction making, and 1 block for displaying the video with object detection predictions. Let's go through the blocks in this model in a little more detail. The first block is a From Multimedia File block, which allows Simulink to read the input video frame by frame. In this block, we must specify the name of the file we want to read, so I will put the name of the video we saw earlier. This then passes each frame of the video to a MATLAB function block, which runs a function I've written called resizeImage. In this block, we resize each frame of the video to be the correct size for our neural network. In this case, that is 416 by 416 pixels. We also extract the current timestamp, as this will be used later to determine the frames per second of the video. From there, the resized video frames are passed to the Deep Learning Object Detector block. This block allows you to import and use an object detection model, and in this case, I have one saved in a MAT file called detector YOLO v2. For each detected object, I want to know what the bounding boxes and the predicted classes are, so I will select bounding boxes and labels as our output ports. These bounding boxes and labels are then passed to another function we've written called annotateImage. This function first uses the information passed from the Deep Learning Object Detector to check if any objects were detected. If yes, it takes the current frame of the video and adds an annotation with the bounding box and the class label around each detected object. Then, this annotated frame and the timestamp we saved earlier are passed to the calcFPS MATLAB function block. In this function, we calculate how many frames are being processed per second, then we add this value to the frame so that we will be able to see how quickly our video is being processed. This also gives you a sense of how quickly the model can process input, which is important in applications where the model needs to be able to process its inputs as fast as it receives them, such as automated driving. Each frame, now annotated with object detections and frames per second, is then passed to the video viewer block. During simulation, this block will display each annotated frame as a video, allowing us to see how the neural network is performing. And that's the full model. Now it's time to run our simulation. With a video viewer open so we can see the outputs, we can start the simulation by clicking on the green Run button. The model will take a few seconds to compile, as indicated by the green loading bar at the bottom of the screen. Then it will execute the compiled model, running each frame of the input video through the object detector and displaying the results. Now, we're hitting about 20 frames per second in this example. If your computer has a GPU, you can tell Simulink to use it by clicking here. If you do this and run the simulation again, this should greatly improve the speed. And that's it. While I showed an object detection example today, there are many other blocks that allow you to use deep learning in Simulink for a variety of applications, such as classification or regression on image, feature, sequence, or time series data. If you want to learn more about deep learning in Simulink or the example object detector we used, check out the links in the description. Thanks for watching.